here. Are you able to see it? Can you able to see? Yeah, yeah. Okay, fine. And till now we have completed this, right? We have completed the top. Yeah, we have completed the top-down parsing. In the top-down parsing, we have seen the, anyway, we have seen the brute force method, and in addition to that, we have seen the recursive descent parser. Let me write it as a recursive descent parsers, and we have seen the LL1 parser, right? So this is based on the top-down, and now we are moving to the little bit next version, that is the bottom-up parsing. In the top-down, till now we are having the, like in the syllabus, we are having up to LL1 grammar only. Okay, LL1 grammar. But if you see the recent gate papers, they're asking the questions based on LL2 grammar and LL3 grammar and LL4 grammar also. So, but this is, as of now, this is not in our syllabus. So, but one day I'll take the class in extension to this LL grammars. I'll inform you when I'm going to take this. Then interested students, you may join for this class. Okay, but this is not mandatory for your regular work. Okay, so if you want to go for some gate level problem, then you can join that session. And that, that session will be pending. Then remind me some other time. I'll take a class on it. Okay, so now we'll go for the next the next classification of parser, that is bottom of parser. And we have seen in the top down parsing, like we are going to, like there will be grammar, right? In the grammar, and we are going to have some string w that we have to load it into the input tip. And after loading the string w, we are going to append with the dollar symbol, right? And we are going to see the one look at symbol every time. And the productions with the grammar, we are going to start with the start symbol s, and we keep on substituting the production with respect to the locate symbol we are seeing from w. And finally at the end we can able to construct the parts tree, and we can able to, we can able to reach the string w from the starting symbol. So that is the procedure we have seen till now. And if we see the bottom of parsing, and one more point is, while we are going to derive the string w from the starting symbol s, we are going to use the top down parsing, right? We are going to use the top down parsing. Just let me make it one change of this. Mm, yeah, okay, okay, fine. And see here bottom up parsing. So in the bottom up parsing, we are going to write the same. We are going to start with the same string, the grammar G. We are going to consider, and we are going to start with the start symbol S. But in the bottom of parsing, so generally we'll see the string W. That string W I load into the input tape. Now what I'll do is I'll read the string first. So according to that string, which part of the string is going to match with the right hand side of production. Generally, this G means grammar G means it is going to have some set of productions, right? So let me write the production P1 is some A derives alpha. Okay, and let me write some production x derives gamma. This is these are the two productions. Just you can think of it. And what is the bottom of parsing is, in the string w, we have to identify which part of the string, which is which sequence is going to match with this right hand side of the production. Okay, suppose the string w is a part of some gamma. W is gamma then the string w is gamma. Now this gamma is matching with the right hand side production of this x. Now what I'll do is I'll reduce this gamma to x. Okay, so here we are going to substitute the left hand side values from the right hand side. But generally in the top down approach, what we did in the top down approach, we are going to start with the start symbol, and we are keep on expanding the productions, and at one level we are going to read the string w. But this is somewhat different. This bottom of parsing is somewhat different. We are going to start with the string w, and we are going to contain some set of strings here, and some part will scan, and that scanned part is matching with any one of the right hand side production of the production that is defined in the grammar G or not. If it is matching, then we can call it as a handle. Okay. So what is handle here, right? I think we have discussed when we are discussing about the like introduction to parser. Okay. So we can call it as a handle. What is handle? Handle is the part of this a small sequence of or a subpart of string W that is going to match with the right answer the production. So if it is matching, so that handle we have to reduce it to left hand side value. Suppose in the string W, gamma is one part. Okay. So this gamma is matching with the right hand side production of the X. Now what I have to do? This gamma, I am going to reduce it to X. Clear? This gamma I'm going to reduce it to. So this procedure we can call it as handle pruning. Let's say this is, we can call it as handle pruning. So that is the procedure we are going to follow in the bottom up passing. In the bottom up passing, we are going to start with the string W and we are applying, recursively applying the handle pruning process till we are going to reach the starting symbol. Okay. So generally as we are a human beings, in which parsing will be flexible and in which parsing will be, efficient. Can anyone answer? So now just I have given you the explanation, right? What is the top down and what is the bottom up parsing? So which one you'll prefer, either top down or bottom up? So generally, as a human beings, we'll prefer the top down, right? Because that is somewhat analysis. For analysis, it will be somewhat easy for us. Okay. But if you go for bottom up parsing, all the parsers, all the machine dependent parsers like LL parsers, LR parsers, it will be very easy for implementing bottom up parsing. Okay, when compared with the TD, okay, top down parsing. So that's what, and we'll see one example, and see here the bottom up parsing. It's a more powerful parsing technology when compared with the top down parsing. And here we are going to design the left recursive, LR grammars. Okay, have you remember like we are having the schedule in the bottom up parsing we are having like two classifications, right? Operator precedence parser and as well as the LR parsers. So in the LR parsers, we are having some LR0 parser, SLR1 parser, CLR1 parser, and LLR1. These are the several parsers. And now, what is the why we have to prefer this bottom up parsing is it is more expressive than LL. Okay, so if you want to construct LL1 parser, that grammar we have to refine it first, right? We have to see left recursion and we have to see non-determinism and we have to see some other parameters. Okay, but if we see the bottom of parsing here, like it can handle left recursive grammars also. Okay, so in the bottom of parsing, even though there is a left recursion in the grammar, no need to define it. As usual, the same grammar we can give it, and it can be implemented for all kind of grammars, all kind of programming languages, and it is easier to express programming language syntax because sometimes we cannot we are unable to we have to represent the recursion and that to be that recursion should be left recursive means we are not going to avoid some kind of situation in that kind of situations like this bottom up passing will be it will plays a important role. Okay, so this bottom up parsing we can implement the shift reduce parsers. Okay, here we can call this this parsing can be implemented with the shift reduce parser. And if you have remembered in the LL1, we are going to implement with the stack, and then the stack we are going to use the two operations, right? Push operation and pop operation. In the very recent class, we have discussed the methodology of push and pop, how we are going to implement it with the stack and all with the top-down parsing. Okay, so same in the same way as usual to it, we are going to implement the parsers for the bottom-up parsing that we can call it as a shift reduce parser. Okay, so this shift reduce parser, it will construct rightmost derivation of a program. Okay, so this is one point we have to remember. All the bottom up parsers will go for rightmost derivation, not only rightmost derivation, it will go rightmost derivation in reverse order. Okay, so while we'll get in the reverse order, we'll see in the next slide. Okay, and this shift reduce parsers can be implemented with the automatic parser generator. Some examples are ACK, and some examples are this one, and it will detect errors as soon as possible. Whenever it is going to detect the errors, it will all the errors will be reported to the error handler. Okay, and it will allows better error recovery also. So that is about shift reduce parser. Not only it's just introduction, but we need to know little things about the shift reduce, how it will works, and what are the different stages under. Okay. So next one, let me go to the next slide and see a top down passing. Anyway, we know, right? So let us take this is the grammar, and this is the grammar production G, and I want to derive the I want to construct the parse tree for it from this grammar. Now I have to start with the S as it is a top down parsing, and suitable production we supposed to choose. That is based on the guessing only, right? Because even as we are having two production, see we are having two production. Now internally we have to think, logically we have to think what might be the structure. So which production I have to replace. So in the same way, it is going to use the leftmost derivation, and with the leftmost derivation, the top-down parser will construct the parse tree. Okay, I think this we have already seen in the last previous classes, right? And now we'll go for next slide. That is a bottom-up parsing. So let me do. Okay, bottom-up parsing. And see here in the bottom of parsing, so this is the grammar we are having. Okay, this is the grammar we are having. Same grammar, S derives S plus C and E. And see here, we are going to start with the tokens and end with the start symbol. That is the bottom of parsing. So let us take the string is this 1 plus 2 plus 3 plus 4 plus 5. Now, what is the task with the bottom up passing? We have to check which part is going to match with right hand side. Okay. So see here, this 1 is matching, 2 is matching, 3 is matching, 4 is matching, and 5 is matching with the number. You can choose one particular number. Okay. Then how we have to choose it? So that's what it will go for the reverse rightmost derivation in reverse order. Okay. So when you see this expansion, then you can mostly you can found the rightmost derivation, but rightmost derivation reverse order means first it will like try to expand this one. Okay, this one is matching with, it will search for you, one is matching with this number, so this one can be reduced to E. Okay, so now again S can be reduced to S. Sorry, E can be see, this E is matching with this one more handle we have found. This E can be reduced to S. Okay, and now this 2 is matching with the number. Now this 2 is reduced to E. Okay. So finally we got the S plus C, right? S plus C. I'm considering only 1 plus 2 option. Okay. So now this S plus C, this reduced production S plus C is matching with this. So this S plus C can be reduced to S. Now we are here. Open parenthesis. S plus 3 plus 4 plus 5. Okay. So again it will check. If you want S plus, then here we need one more expression E, right? So let me expand it. So 3 here, this 3 is matching with this number. So now I can reduce this number to E. Means this 3 I can reduce it to E. Plus as it is. And what about 4? 4 I'm not performing at the time. Again this E can be reduced to S. And now this 4 is matching with this right hand side of the production. Now this 4 can be reduced to E, and now S plus C. Again, what is this expression? S plus C. So this is the expression, right? Now this I'm going to make it as yes. Okay. So finally, what is the expression now? S plus parenthesis yes plus 5. Okay. So we are here now, and see here. This yes, can I reduce this yes? Which part is matching? This part is matching, right? This part is matching with E, right? Now I'll reduce it. S plus E. S plus C plus 5. Now again this part is matching. This S plus C is matching with this, right? So I'll reduce it to S. Okay. So now what about this 5? This 5 is also matching with the number, right? So this can be reduced to E. And finally this S plus C can be reduced to S. Clear? So now we have started with the string W, and we are going to read the, we are going to reach the starting symbol S. So this procedure we can call it as a handle pruning, and in this way the bottom of parser will work. Okay. So just let me see progress of the bottom of parsing, and this is the string we are going to see initially, and this is the string we need to be parsed. This will give you the difference between this is the scanned string, this is the unscanned. Okay, initially we haven't read the string, and now we have read the string, open parenthesis 1. So this is the scanned input. Let me write it as some scanned input. This dull portion is scanned input, and this portion is unscanned input. So this PPT you can get it from, I have given you one resource link, right? Cornell University. Okay, from that university you can get this link, PPT link. Okay, this one I have scanned. So in this scanned input, I have found as a one handle because this one can be E. Okay, so now in the second step, again this E I have found it as a handle. Now it can be reduced to S. Clear? So that now I have to read some other input. What is the other input? Now I am reading this lookup symbol 2. Now is 2 is matching, is 2 is handle, S2 is also handle. We have substituted this, we have performed the handle pruning on 2, that we got the E. And now S plus. In the same way, this process is going to be continued where with the scanned input and unscanned input. In the bottom of parsing, like even though there is some input string, at a time we can able to see only few a few portion of a string only, not much more than this. So unscanned portion will be more when compared with the scanning portion at the initial stages. Okay, so from this only we can able to we can able to form the handles. Clear? So any doubt as of now? Are you here? Are you there? Okay, it's okay. I hope. Okay, then we'll go for next slide. Bottom up parsing. So this is the way how we are going to get the parsing. Okay, and see here only this is not Parsi is okay, but from here it will read. Or if you want exact, then it will be like this. Initially, it will be 1 plus 2 plus 3 plus 4 and plus 5. If you want clear understanding, you can start from here. One you can reduce it to some S and E, and this you can, but how the partial will look like. The partial always starts with the root. The root will be S only. But we are going to write all the terminals here, and we are going to keep on reducing the values, reducing the leaves until we are going to read the start symbol S. Okay. Now we'll go for the next slide. So this is the top down versus bottom up parsers. In the bottom up, no need to figure out as much of the parse tree for a given amount of input. Okay. So shift to reduce parsing. So parsing is nothing but a sequence of shift and reduce operation. It's like a push and pop only. Okay. So whenever we have encountered pop operation when we are discussing about LL1, we are just keeping like we are popping out one element from the stack, and in place of it we are pushing something, right? So in the shift reduce parsing also, we are going to use one stack. In the stack anyway there will be two options, right? Push and pop operation. The same way here we are going to call it as a shift operation as well as a reduce operation. Shift operation means it's like a push operation. Reduce operation means it's like a pop operations. So parsing can be done with the shift and reduce operations. And here parser state is a stack of terminals and non-terminals. Okay. Here we can push we can put some variables. We can put some non-terminals also. And unconsumed input is a string of terminals, because we have to consider parse for string of terminals only, right? So it's like what the statement is we are going to consider in the programming language. For the statement, we have to construct the parse tree. So in the same way, there will be some unconsumed input. Unconsumed in the input means we haven't seen till now. So this is unconsumed input as of now. And the next I have read open parenthesis one. Now this will be the unconsumed. And the current derivation step is always a stack plus input. Okay. So in the stack, what we are having, and as well as up to which part we have covered. That is the shift reduce parsing the example. And see here, here parsing is a sequence of shift and reduces. And shift means move lookahead token into the stack, no effect on derivation. Okay. So means here we have in the stack contents are initially it will be dollar. Okay. Like dollar will be representing end of the stack. So in the stack I have pushed one open parenthesis symbol as a part of input. Now what action I have to take is I'm going to shift one. Shift means that is one action. So in the stack this one you have to push onto the stack. Okay, so one will be goes into the stack and the next will be the look at symbol. Okay, so next reduce. Reduce means we have discussed it. Replace symbols gamma in top of the stack with a non-terminal x corresponding to the production x derives y. Suppose if there is a x derives y production, sorry, x derives gamma production, then if gamma appears as a top of the stack from the stack, that you can pop the gamma from the stack, and in place of that gamma you can place the x value. So this is the stack. So let me write it here. This is the stack. Dollar is the top of the stack, and gamma is the top of the stack. Okay. So now what I have to do is in the reduce option, you you remove this, you pop this gamma from the stack in place of gamma, because that is a token. So that is a handle corresponding to this production. So in this production, X gamma is one production. So this gamma is a part of it. Now we have to replace gamma. We have to replace x in place of gamma. Now this can be changed like this: dollar at the top of the stack. So in place of gamma, I have placed x here. That will be the top. Okay. So replacing dollar in the top of the stack with the non-terminal x. X is what? This production left-hand side value corresponding to the production x derives gamma reduces rightmost terminal. So let us take the stack contents are s plus c. This plus s plus c production is going to match with this. S derives s plus c. Sorry, here it is. S derives s plus c production is there. So this s plus c is matching with this production. So now you can pop out this s plus c from the stack. In place of that, you can place s. So that is the reduce. So whatever we did in the LL1 as a part of pop operation, in the same way here we can call it as a reduce operation. So mainly here shift will be operating operating with that four different functions: shift function, reduce function, as well as the accept and error function. Okay. So this is about the shift reduce parsing. So let me go for next slide. Okay, I think you can see this. So what is the input? What is the production we have considered? When I have to reduce? So this we will discuss later. And here the problem is, how do we know which action to take, whether to shift or reduce? In the LL1 parsing, we are having some parts table, and the corresponding to the terminal and variable, we are going to choose the production. That production we are going to replace it. But here the problem is, which action I have to take. Either we have to perform shift or we have to reduce. And see here, sometimes can reduce, but should not. When it will happen, if there is a epsilon production, then like reduction is always not possible, right? Sometimes we can reduce more than in one way. So these kind of problems we can face, we can encounter while going with the bottom up parsing. And see here the action selection problem. Okay. So given stack, the sigma and the lookup symbol b, the parser will go for it will shift beyond to the stack, or it will reduce some production x derives gamma, assuming that the stack has a form of alpha gamma. It means stack is having the sigma and the lookup symbol is b. So in such case, which action the parser has to perform, whether it has to perform shift operation, whether it has to perform the reduce operation. Okay. So if the stack has formed some alpha gamma, should apply the reduction exercise gamma depending on the stack prefix alpha. Okay. Here alpha is the different for different possible reduction, since gamma has by different length. So if you want to know all these sentences, first we have to discuss about bottom up parser. Then you will be able to understand what they are saying. Okay. So as of now, it's like a simple reading only. But once we solve the problems, like how we did for LL1, in the same way, if you solve this, then you will get to know. But basic ideology, why we are going to discuss all these parts, I think you may get that out, like why we are discussing all these kind of parses and all, because we are going to do with the programming languages, right? Like if you take C, or if you take C++, if you take Java, like if you take the .NET, and if you take Python, whatever the programming language you are going to take in, we are going to take. So definitely for every language there should be a compiler, right? Without it, it's very difficult to run the program, execute the program. So in every almost all kind of programming languages, we have to design some compilers. We have to design the compilers in order to make it use of specific programming languages. So definitely the compiler will be requiring. So here, how to design the compiler is that we are discussing, especially in the compiler part, how we have to parse it, how we have to eliminate the unnecessary things from the source code, what are the how we have defined the statements, and whether the statements we have defined, is it really matching with the programming language syntax or not. Okay, if it is really matching with the programming syntax, is it having some logical meaning or not? So everything we are going to learn in the compiler design subject, because without compiler we cannot able to run any one of the codes, right? So that's what we are discussing. Okay. So as a part of this compiler, as a part of second phase, syntax analysis phase, we are discussing the LR parsers. Okay. So this what this LR parser will do is, so some X compiler, if you take any X compiler, this compiler will read entire code in the Python, or it will read entire code in the .NET, entire code in the Java, entire code in the C++ or C. It will try to construct parts trees. Parts trees means just it's give the location where the control goes from where to where and how it will be. Okay. So whatever the programming language it is there, so the parser will construct one unique parts tree. Okay. For the source code which you have been submitted to the compiler. So in order to construct this parts tree, are you getting? In order to construct this parsing, we are going to depend upon the bottom-up parsing or the top-down parsing. As of now, we are depending upon the bottom-up parsing only. Or the newly implemented programming languages will go for bottom-up parsers. So this bottom-up parsers will construct the parsings for the codes we have written in most of the programming languages. Okay. So how it will during this conversion, how it will convert, how it will construct the parsing, what is the methodology to construct it, what are the different actions it will take, so that we are discussing. Okay, so don't deviate from the major topic. The major topic is this. Okay, so here we are going to discuss about the parsers and how the parser is going to build the syntax trees and all. Okay, so now the goal here is it will be somewhat they have related to the DFAs and all, because if we take any some string also, how we'll get to know string is some word or whatever it may be. Anyway, that can be done with the DFAs. Anyway, these DFAs we have learned in the flat, as well as we have learned in the lexical analysis phase also. Okay, so here in the bottom of parsers, we are having some LR0 parser as a first classification, and we'll start from the next class onward, all the bottom of parsers. So this is about the states and all. I'll give explanation along with the examples. Okay, so uh, let me give let me write in some other thing also. I'll share one app. Okay. Okay, see here, we have seen the LL1 parsing algorithm, right? LL1 parsing algorithm. So I think we have seen the LL block diagram also, and now we'll see the bottom-up parsing. The bottom-up parsing block diagram. Bottom-up parsing block diagram. Block diagram. Okay, so what is the bottom-up parsing block diagram here is, these are the common parts. We are going to have the input tape, and we are going to have the stack, like we have discussed in the LL1 parsing. And here we are going to have the bottom-up parser algorithm. So if you are inputting LR0, then we have to replace this bottom-up algorithm with the LR0. If you are using SLR1, then we have to use SLR1 algorithm. If you are using some, okay, so on so. This is the concept. And it will depends on the parts table. It depends on the parts table, like how we did in the LL1 parsing. Here also it will depends on the parts table. And by considering, from the input, from the stack, and from the parts table, it will generate the output. What is the output? It will go for the parts D. Okay, and it will see the grammar. Now, how to construct parts table in the bottom of parcel? So that's the question now. So this we are having a nice answer for it. So here the question, there in the LL1, how we have constructed the parts table with the all variables and with all terminals. I have constructed the parts table, and corresponding entry I have filled the values, right? What are the values I have filled? That is based on the productions. And now in the bottom of parsing, that the columns can be divided into two parts, and the two parts are action part and go to part. Action means which action I have to take. Go to means where I have to go. Okay, so this is one methodology. Again, in the actions, we have to write the terminals. Suppose I'm reading one terminal from stage one, and I'm writing the terminal from stage two. So what is the action I have to take? Go to means where I have to go. Not exactly variables. We can call it as items. This is items. We'll discuss later what is items and all. So as of now, just you can try to understand. And every column will refers to items then. Items. Every column is with the items. Okay, so this is a parts table. So the parts table is going to have action part and go to part. In the action part, we are going to write the terminals. In the go to part, we have to write the items. So every row will refer to the item. So now corresponding to item and terminal, what action I have to take, that we'll discuss. And what go to part, this we'll discuss in the next classes. What I have to fill here, what I have to fill here, what is item first, what is action function, what is go to function, we'll discuss in the next classes. And I'll give you some what are the actions as a brief idea. What is the action as a brief idea? That is, this input tape, right? What is this input tape? Initially, the tape is going to load with the string. It will be divided into number of cells. Every cell is capable of storing one character at a time. There will be tape header, which is going to point out one lookup symbol at a time. And even stack also, stack is going to have some variables and the terminals as the top of the stacks. And what is the top of the stack every time? That information will be sent to the bottom of parsing algorithm. Now it will read the input tape, it will read the stack, a stack of the top of the stack, and based on this, it will consult the parts table what I have to perform, which action I have to perform, or which state I have to move. So that can be given by the parts table. So based on all these, we are going to generate the output. And coming to the actions, like there will be some actions here. One is the shift action. It's very difficult to write everything, so that's what I'm orally giving to you. Just you can maintain the running notes to make benefit out of it. Reduce function, reduce or not function, reduce action, shift action, as well as the accept action, as well as the error. So these are the four actions available with the bottom of parsers. And what is shift action is? like if the handles does not occur from the topmost symbols of the stack, then we have to perform shift. Means suppose from the input I have read some alpha. Okay, so this alpha I cannot able to form, or I cannot able to match with the top of the stack. It means match doesn't occur. So in such case, what I have to do, you have to shift. You have to place this alpha as the top of the stack. Means you have to insert this alpha into the stack. I'll insert the alpha into the stack. So that is shift operation. So what is the symbol? What is the lookup symbol you are seeing? If from that, if it is not matching, if it is not matching with any one of the handle, then I have to place it in the top of the stack. Clear? So next one is reduce action. What is reduce is from the topmost symbol of the stack, if you are able to form some handle, now you can replace that, and in place of that, you can place LHS variable onto the top of the stack, and you can reduce this production to some, some A or whatever the variable it may be. That is a reduce action. So if we say in simple words, if handle occurs from topmost symbol of the stack, then we are going to perform the reduce action. Okay, accept action. So what is action? Yeah, accept is when we have to call the action. Accept is after reading the complete input string. If the stack contains the start symbol as the top of the stack, then the input string is accepted. It means we have to we have to check in the same way like LL1. In the input type, we have to check, are you able to read the dollar symbol from the input string? It means what? I have read the complete input string. And you just consult the stack here. In the stack, are you able to touch the dollar symbol? If you are able to touch the dollar symbol, means you are at the bottom of the stack. But this is the bottom of parsing, right? So here, as a bottom of the stack, instead of dollar, you should touch the start symbol. Clear? So in that case, the action accept will be called. When it is going to call accept action, in the input type, you are going to read the dollar symbol, and at the same time, if you are able to read the star symbol of the grammar as the top of the stack, then the string can be parsed successfully. Otherwise, it will lead to the error. So that is the error condition. What is the error condition? When you are able to read the dollar symbol, and that time, if the stack, the top of the stack is not ready with the start symbol, it means the string is not being parsed. Or else you are going to reach the bottom of the stack, and that time if you left with some of the variables in the some of the characters in the input string, even that case also we are going, it will lead to the error. Okay, so this is about the actions, and still we need to discuss something regarding this go to item sundown, and that we'll discuss in the next class. Okay, so any doubts as of now? Any doubts? Yeah. If no doubts, you may leave them. Yeah, we'll discuss in the next classes the remaining concept. We'll start with LR parser. Uh, and as of today, you may leave. Yeah, okay, fine then.